So section 2.4, we want to look at the net rate of change, or excuse me, the net change between a couple values on a function. So that'd be 4 and 6 here. I want to find how much the function has changed. Now that's really just going to be the change in the y coordinates. So an easy thing to do here is just plug in the values for x into our graphing calculator maybe. So I've got our function defined in y3. Let's go to the table function, or the table menu, pull up a table there, and I'm going to take a look at the function at 2 points, 4 and 6. So that gives me two values. It gets me negative 46 and negative 106. And those are good values to look at because the net change is just going to be the difference in the y coordinates. So it's going to be net change is going to equal negative 106 minus negative 46. So those two negatives there in the middle cancel each other out, becomes a positive. Negative 106 plus 46 is going to be negative 60. So that's your net change. Now how's that different than the average change? The average change is really just the slope of a line between those 2 points. You might remember that that's going to be m equals y2 minus y1 over x2 minus x1. Well, essentially I've got my points there, right? I've got 4 and, let's see, let me write them here, 4 and negative 46. And then my other point is negative 106. Yeah. How about negative 6? Yeah. How about positive 6? And negative 106. So I can call this my x1, y1, and this is my x2, y2. The average rate of change on this one is just going to be the difference here, negative 106 minus negative 46 over the difference in the x's. So it's going to be 4 minus 6. Make sure, how about 6 minus 4? Make sure you subtract them in the proper order. Now I already know the numerator is negative 60, the denominator is 2. So I get negative 30 for the average rate of change. Okay, great. Let's keep going. I had kind of a follow-up one here. The follow-up one is the one that you should be ready for on the exam. Quick question, yes?
How do you get the negative 60?
How do I get the numbers negative 60?
Yeah.
I just added negative 40 or negative 106 to positive 46. Did I do my arithmetic wrong?
I don't know if that's what he was asking, but I think what order specifically do you do it? So I'm also kind of.
So sure, it's always the rightmost point minus the leftmost point. So this value minus this value. So I'm assuming you know if you have A and B are your values here. This one is always greater than this one. You always do the value of the function at B minus the value of the function at A. So the rightmost minus the leftmost. Now, it could be increasing, it could be decreasing, could be either way. But that's the way you'd plug them in. Okay. Let's try and find the average rate of change for these 2 points. Now that one's going to be a little more challenging. It is going to be something that I'll test you on, so it's worth looking at. Let's see here. So I'm going to do another t-table. X, f of x, 2 minus 3x squared. This time it's 4 and 4 plus h. Now f of 4 we already calculated was negative 46. F of 4 plus h, you're going to have to be a little bit careful on that one. So let me do that here. F of 4 plus h. Four plus h, 4 plus h. Now, in doing this one out, you're going to square binomials so much that it's probably in your best interest to be kind of good at that stuff. And if you actually took the time to FOIL this out, multiply a plus b times a plus b, you get a squared plus ab again. So you get that middle term twice, 2ab, and then the last term squared. So, okay, great. How does that help us out here? Well, if you're good, you can square this out the same way. You want the n terms squared, so I want the 4 squared and I want the h squared. And I always borrow that 2 here just for my own crutch. 2 times a times b is going to be your middle term. So let's see if you can't square that out in your head. There's nothing wrong with squaring it out longhand if you're not comfortable doing that. I mean, the bottom line is you want to get it right. So don't do anything too cute if you're not comfortable with it. But let's take a look here. I should get a 4 squared, that's 16. H squared over here. And then 2 times 4 times h. What does that give me? 2 times 4 times h.
8h.
8h. So that's your middle term. Let's distribute the negative 3. That's 2 minus 48 minus 24h minus 3h squared. And I can combine like terms here and get negative 46 minus 24h minus 3h squared. So that goes up here. So negative 46 minus 24h minus 3h squared. If I want to find the average rate of change between these 2 points, then it's going to be the difference in the y coordinates divided by the difference in the x coordinates. So let's go at it that way. Basically, we've already calculated f of 4 gave us negative 46. F of 4 plus h gave us negative 46 minus 24h minus 3h squared. The next thing I need to do is I need to find the difference in the y coordinates, because my slope is just that. The slope is going to be y2 minus y1 over x2 minus x1. It's going to be the difference here. So sometimes I call this delta y, f of 4 plus h minus f of 4. That's going to be this term here, minus 46 minus 24h minus 3h squared minus negative 46. So all I'm doing is I'm subtracting the y coordinates, and I get some nice simplification. Does anyone see what simplifies here?
The 46 and the 46.
Yes, perfect. The 46's. That negative, that's minus negative 46 becomes a positive. Positive 46 and negative 46 cancel each other out. So I end up with negative 24h minus 3h squared. And let's zoom out a little bit. There you go. Get that h squared in there. So that's the difference in the x coordinates. Or excuse me, that's the difference in the y coordinates. The difference in the x coordinates, 4 plus h minus 4, the difference in the x coordinates is just going to be h. So to finish this off, I want to calculate delta y divided by h. That's our last step. And I gave this the name delta y just so that I didn't have to write all this stuff here. All I'm going to write is negative 24h minus 3h squared over h. And I'm going to take the time to factor out that h from the numerator. Why did I bother to factor out that h from the numerator?
So we can cancel out the one in the denominator.
Perfect. Because that's going to cancel the one in the denominator. And it leaves me with my answer, which is negative 24 minus 3h. Nice. Now calculus, that'd be one more step, but for us, we're done. So we're in good shape there. Okay. Let me show you another one like that because you're going to see it in the homework. So it's tougher. I wouldn't put one quite this tough on an exam, but there is one in the homework. So let's take a look at it, and it's kind of a repeat of what we just did. F of t is 8 over t. We want to find the average rate of change between t equal a and t equal a plus h. So this is even a little bit more abstract than the last one because I don't have an actual value here. I've just given an a. A is just some number. All right. So, well, it's going to work the same way. So I'll have t and f of t. At a, the function would be 8 over a. Okay, not so bad. How about at a plus h? Well, plug this into the function and I get 8 over a plus h. Now, there's a couple more things we need to do. First of all, I need to find the net change. That would be the difference in these two. So, okay, let's take a look at the difference in those two. That would be, so the net change, or basically what I call in delta y, equals 8 over a plus h minus 8 over a. Now, if all they're asking you for is the net change, WebAssign should actually take that as your answer. No. For the second part of this, you're probably going to need to do more work on this, so let's just do it here. We need to combine this and get like terms. So let me write that as 8 over a plus h minus 8 over a. What's the lowest common denominator for something like this? What's that LCD?
Can you just do plus h to the a, or can you not do that?
Can't do that. This whole thing you've got to regard as one term. It's a plus h. So we need an a and an a plus h. Both of those have to be part of our LCD. So let me put parentheses around this. From this term, what am I missing from my LCD?
H.
A. The a, right? So I'll multiply by a over a. What's this term, what's this denominator missing that's part of my LCD?
H.
Just h?
No, a plus h.
A plus h, there you go. A plus h, a plus h. So let's clean this up a little bit. That's 8 times a over the LCD minus 8a plus 8h, again, over the LCD. So I distributed the 8 to both of those terms there, right? Now, these have a common denominator, so I can subtract their numerators. The one thing you got to be careful of right here, and it would ruin everything that you've done if you forgot this, but that negative has to distribute itself to both terms. And that fact that it's negative there helps out, at least with the first part, because those two cancel each other out. And finally, you're left with negative 8h over a times a plus h. And all I did here is I wrote the LCD as opposed to just writing the letters as opposed to the actual expression. So that's the third step, and that's the hardest step, is to get that change in y. But notice all you did was you subtracted this y coordinate from this one, or other way, this one from this one. The last step in these calculations is to do delta y divided by h. So I got to take this expression and divide it by h. So let's take a look at what that's going to come out as. Negative 8h divided by a times a plus h divided by h. All right, well, let's think here. This, in the denominator, I could think of as h over 1, right? The advantage of thinking of it h over 1 is that now I'm dividing a fraction by another fraction. What's the trick when you divide by a fraction? What do you have to do? So you're going to multiply by the reciprocal. The reciprocal of h over 1 is 1 over h. So, okay. Are you guys almost ready to be done with this one? Lots of nods out there? Yeah? Okay. The h's cancel. Whew. So after a mere 10 minutes of work, we get to our final answer, which is negative 8 over a times a plus h. As strange of a thing as it seems, this actually does have applications, real world applications. So, there's your average rate of change there between those 2 points. Did I go over any of that too fast? Would you like me to go over something a little bit more? All right. A little bit more by way of review here for us. One of the things we've talked about in this class is increasing and decreasing functions. What would you say about these functions? Are they all increasing? Are they decreasing? Is there a mixture of them? What's going on with them?
They're all increasing.
They're increasing at different rates.
Yeah, oh, well said. They're increasing at different rates in different ways. This one's increasing steadily or at a constant rate, right? What's happening here? This is stuff that we experienced with the coronavirus. Is that it started out slow and then started increasing and increasing and really increasing at a faster rate. So not only is this increasing, but it's increasing at a faster rate. Not true here. Here it's increasing, but it's increasing at a slower rate. It's slowing down. Let me take a look, see if I got this one open still. I think I do. No. Where did it go? All right. Just give me a second here. Open up. There we go. So, a friend of mine from Berkeley High School, Todd Fedor, has been keeping track of the data from the pandemic. And I took data from cases, new COVID cases in Michigan from February 22nd to June 27th. And I fit this nice curve to it. Okay. Now let's take a look here. Starting at 0, this curve is increasing until we get to this point. But right here, it changes its behavior. It goes from increasing at an increasing rate to increasing at a decreasing rate. Basically, it starts slowing down. You're approaching a top. And then it starts decreasing. And then over here, it's actually decreasing at an increasing rate. So it's not only is it decreasing, but it's getting faster in its rate of decrease. So just wanted to show you that, you know, this stuff has actual applications. Now, you're not going to be required to find stuff like this in this course, but if you see it, maybe you'll recognize it. Okay. Any other comments or questions there? I guess the last thing I'll say is this one. 3 downhill skiers ski the same race, ski the same course, but they do it in different ways. B is just steady Eddie, right, all the way through. What happens to A? A starts out fast, and then what? Slows down. C starts out slow, and then picks it up, but they all get to the same place at the same time for a 3-way tie. So, all right, that's about it for the section. Good luck. Reach out if you have questions on the homework.